So again, just to give you a brief recap, so the way language model will be used for information retrieval is basically we will be replicating the query generation scenario from the given document model. So we will be considering each document as its language model, and then we will be computing the generation probability of the query from that retrieval model, from that document model. So essentially, we'll be ranking document based on probability of D given Q. It is not the exactly this thing. So here, probability of D given Q is, as the only thing that we are being observed is Q, the query. So containing say Q1, Q2, and say Q1, Q2, Q3. So what is the probability that the document, our document, will be generated from the query? But as we have discussed in the last class, the size of the document is expected to be much more higher than the size of the query. So the generation of a word entity, of a text chunk containing 100 terms from another model, let's say of containing 3 terms, is essentially not that easy to realize. From 3 terms, how can we actually generate 100 terms? Isn't it? So for that, what we will be doing is we will be using Bayes, and we will be extending this probability of D given Q into probability of Q given D. As we have discussed, the other two parts, particularly probability of D and probability of Q, which are basically the prior probability of the selection of the document and the selection of the query respectively, we can exclude them. Why and how? Because what is, how or why we can ignore probability of Q? Given the query Q, our task is to rank or score all the documents, all the docs in the collection, isn't it? Now, so if there are say 1,000 documents, or say 10,000 documents, all of them will be scored, right? Now, probability of Q is what? The prior probability of the query. Now, this part will be same for all the documents, right? Now, essentially, if we change, if we consider some prior probability of the query, then, essentially, there will be no change in the rank of the individual documents, because all of the documents, while computing the score, will be divided by this same entity, same quantity. So we can exclude them, or we can exclude that, basically probability of Q. And probability of D is the prior probability of the selection of the document. This we can actually consider, consider putting some weight based on its quality, based on its popularity. That is, more popular document, more frequently accessed documents can be given higher priority. And of course, we can use the famous page rank of the document to be considered as the prior probability of the selection of the document. But for, essentially, all this, setting this probability will be changing the rank as well, unlike this probability of Q, because different documents will be having different prior probabilities, isn't it? Based on, say, different reasons. Maybe documents having different quality, different popularity, or different page rank. But in this part, we will be considered it as uniform as well. So uniform means we can just simply ignore it. So, and probability of Q given D is the probability of generation of the Q, the query, given the document D. So what we were we had was a query, right? The task was to check how likely that a document, a relevant document will be generated from the query, which was basically probability of q given the probability of the document D given the query Q, and uh, here in this, what we have done is using the Bayes theorem, we have reduced it to make it in the as the other way around. What is the probability that, so excluding, we will not be using this. Instead, what we'll be doing is probability of computing probability of the generation of the query from the document, and based on this we will be scoring the document. Okay, so this is just the graphical or pictorial representation of the process. So basically the thing is, if the user had the relevant document in mind, he will be generating the query based on some particular terms which are appearing in the relevant document as the query terms. So let's say D2 is the relevant document here. Now the user will be selecting some terms from D2 as the query terms. So basically considering D2, how likely the query will be generated is basically all about the query generation process in language model. Now a document will be scored based on this basically probability of Q given D, basically probability of generation of the query given the document. And as the query is containing multiple terms, what we can do is we can consider the individual query term generation from the document. So basically here what we are doing is, so product over all the query terms in the query, and we are computing the generation probability of that particular query term from that document. This is what we are doing. So if we look at this from the query generation point of view, essentially what we are doing is we are computing the query term generation probability. We are computing the query term generation probability, and we are making the product of individual probabilities.